Do the notes for 8th grade, elements, compounds, and mixtures. So I'm using the notes that are in your packet. If you have Carter, then your packet may actually have the counting atoms notes in front of the compounds and mixtures notes. But the compounds and mixtures notes are going to be on the notebook paper that has the thought bubbles on it. It says pure substance on the far left, like Cornell style notes for this. If you have Mr. Topps, then he should have given you the packet that has just the compounds and mixtures in it. And then it's followed by some practice and some worksheets, and we'll look at those here in just a second. So let's get into this. So for a pure substance is an property with fixed chemical or let's back this up a second. It's matter with a fixed chemical or physical properties. So it's matter, goes in that line, matter with fixed physical and chemical properties. Then looking at specifically, we have elements versus atoms. So our atoms we talked about last week, they are made up of protons, neutrons, electrons. I gave you the little carbon square on the periodic table. So our ape man that we talked about as well, with the atomic number is my protons and electrons. It's my ape. And then my mass is my atomic number plus my neutrons. So it's my ape man that we get through. But as far as our elements go, they're going to be made of the same type of atoms, so same atoms. They're found on the periodic table, and they can't be broken down into smaller substances. So if I'm filling in my blanks, same atoms found on shorthand, PRTB, can't be broken into smaller substances. So with our elements, remember it's the periodic table of elements, not the periodic table of compounds or the periodic table of mixtures. So if I can't find it on the periodic table, then it's not going to be an element. I can't find water on the periodic table. I can find the pieces that make up water. I can find the particles that make up water of hydrogen and oxygen, but I cannot find actual water listed somewhere on the periodic table. So moving into compounds. Compounds are two or more atoms that are chemically combined together. So compounds are chemical combines. Compounds are chemical combinations. There is a locked number or a set number of ratio in elements. So locked number or ratio of elements. They can be separated chemically. So separated chemically. And what it means by locked number or ratio of elements. So if I look at the NH3, NH3 makes ammonia, and it's always going to make ammonia. If I put NH4 to it, it's something different. If I look at CH4, that is chlorofluorohydrin. That makes up explosives. So if I change the amount of carbons or the amount of hydrogens, then I mess up how big the boom is going to be. So looking at, again, this is still with talking about compounds. There's nothing else to write. But we're looking at, there's made up of specific elements with specific ratios, and they're always going to be the same. H2O is always going to be water. H2O2 is hydrogen peroxide. You don't want to drink that because it will hurt you. There's always going to be a chemical formula for a compound. So we have NaCl, which is sodium chloride. That's just regular old table salt. And it can only be separated chemically. I cannot separate salt and make it sodium and chlorine physically. I have to go through a chemical reaction for it. I can separate water and salt. I can make those separate with a physical reaction because those are considered a mixture and not a compound. So with sodium chloride, and then the video that's with this is a Brain Pop video, and I've linked it in the PowerPoint. And I've also linked it in the Canvas assignment. So you're going to go watch that if you need more help about it. And it's going to break down the different basics of what is a mixture, what is a compound for the gen ed classes. And then Ms. Carter's per AP classes, there's a TED Talk link that talks about the different types of mixtures and compounds. So we get into mixtures. So with mixtures, it is an impure substance. So impure substance, that's what goes on the first line. They're physically combined together, meaning it's just like I stuck them in a bowl together. There's an indefinite ratio, so there's no specific number or ratio. And I can separate these things with physical means. So I can either make it go through a state of matter change and it would separate it, or like in the picture, I can pull the iron out with a magnet because it's just a physical separation. So still don't have to write anything. We're just kind of reviewing what makes a mixture a mixture. So combination of two or more substances that are not chemically combined or linked together. The substances are held together with physical force, not chemical force. There's no chemical change happening. I still have the same properties and the same stuff. I still have the same substances. And then each item is going to retain its property in the mixture. So if I look at the tap water in the image, I have the blue water molecules, but then most tap water has fluoride, has chlorine in it, and then there's some other like little tiny elements that they put in it, like they put fluorine in it for our teeth. So those would be the other elements. To look at it, it looks like all one big thing, but realistically it's multiple things that they're mixed together that I can't just like chemically react them. I can put a filter in them and put the water through a filter and then get what's called distilled water, where it's just water molecules. It would be like pure water. Then looking at this trail mix. So we all love trail mix. Well, most of us love trail mix, unless you have a nut allergy. Anyway, if I'm looking at this picture, the question I have to ask myself, if I'm trying to determine if it is a compound or a mixture, is if it is a mixture, can I separate with my hands or a small device? Could I separate them into smaller pieces? The answer with this trail mix is yes. I could physically separate out the cashews. I could physically separate out the almonds and the raisins and the chocolate covered peanuts. And then I get into those M&Ms. So the M&Ms are a little bit different because I made them go through a chemical change because I cooked them, right? Because I have to cook it to make chocolate. Because I melted the chocolate, the sugar, and the milk, and the cocoa powder. That sounded really weird. Cocoa powder. I get the chocolate compound that we look at because I can't physically uncook it. So I can't pull them apart as I could with the other pieces of the trail mix. So our chocolate is considered a compound because I can't easily separate it. I can't uncook it. Whereas the actual mix as a whole would be considered a mixture. So on your notes at the bottom of the left-hand side, it says sorting ? And then it says mixture, element, compound. So we're going to really quickly write these kind of one-line definitions down. So for element, they're out of order and I apologize. For element, so it's the second one on the list, it's going to contain one type of atom. So one type of atom or pure substance. For compound, contains two or more atoms chemically connected or chemically joined. Mixture, two or more physically connected or physically joined. So element, one type of atom or pure substance. Compound, two or more atoms chemically joined together. Mixture is going to be two or more physically joined together. So then let's look at these pictures. So we've got a couple pictures. You don't have to write anything down. We're just going to kind of go through them, and then I'm going to pause for a second to see if to give you a second to think, and then I'm going to tell you what they are. So this will be kind of like a Dora the Explorer kind of game, sort of. So on the first one, are the picture of the rocks an element, a compound, or a mixture? So I'll give you a second to think. Drink my water. So this would be an example of a mixture. I have different types of rocks. I have different sizes of rocks. I could physically separate the rocks together. Notice I didn't say the water and the rocks. I just said the rocks themselves. So the rocks in and of themselves, I can separate and put them into different piles. If I was talking about a specific rock, then I get more into that compound because they're often chemically connected together. So for this one, copper. Copper, is it an element, a compound, or a mixture? If you said element, then you are correct, because the Cu is the copper symbol on the periodic table. Then we get into table sugar. Is table sugar an element, a compound, or a mixture? So if you look at the C12H22O11, that is the actual chemical formula for the compound that is known as sugar. So this is a compound. An element, a compound, or a mixture for a diamond. There's a hint in the bottom corner. So a diamond is a pure substance because it is just pure carbon under high amounts of heat and pressure, and that gives us an element. So a diamond is an element because it's just made of carbon. The tea in the cup, so not the cup, the tea in the cup, is that an element, a compound, or a mixture? So is it a pure substance chemically combined together, or things put together physically? So this one's kind of tricky. This one falls under mixture because it's water and then the tea particles. It's water and the tea particles, or the tea, like once it's dispersed, the leaves, they open up and they kind of turn color. So this one's tricky, but it's a mixture. Salt, is it an element, a compound, or a mixture? So there's a hint in the bottom corner. So if you said compound, then you were listening beforehand, and it is. Sodium chloride is a compound. Neon gas, is that an element, a compound, or a mixture? So neon gases light up these neon signs. The blue ones are made of argon. The orange ones are actually neon. So both of these would be an element, and they would be found on the periodic table. So a salad, is a salad an element, a compound, or a mixture? Hopefully these are getting a little easier. And hopefully you said mixture, because there's lots of different types of salad or lettuce in that salad. Pure water. So pure water, is that an element, a compound, or a mixture? So because it says pure water, we're going to have to go with compound. If it said tap water, then that would be a mixture. So this is where it gets kind of tricky. You have to pay attention to the details. So pure water is just going to be H2O. That would be our compound. Then we get into lemonade. Lemonade, if I look at the picture, it's water and lemons and probably sugar. So because I said and in between each one of those, it's going to make lemonade is going to be a mixture. Like with the tea, it's water and tea leaves. So oftentimes, not always, but oftentimes, if there's an and in the list that's happening, and it's not just a bunch of elements listed together, but like with this one, water and sugar and lemons, then that often means it's going to be a mixture. So you have this picture, and I'm going to walk through it, and then you have this in your notes. And so your notes have spaces for you to fill in the blanks. There will be an image that's uploaded to Canvas that's got some basic stuff filled in for you, just to help. But if you're looking at your chart, it says pure substance and mixture, just like the picture on the thing says pure substance and mixture. So variable composition just means, is it made of different stuff? So is it made of different stuff? No, then it's a pure substance. And then I asked, can it be separated into simpler substances? No, then that means it's an element. So that if I'm looking at the notes, that left-hand box next to where it says chart, you're going to write the word element in there. And then my example is helium. It's at the bottom of the image there. And then you're going to sketch it, and you can pause this if you need to. You're going to sketch it, the picture of those helium molecules kind of bouncing around. So back up to the matter. Matter. Is it made of different stuff? No. Pure substance. Can I make it into smaller stuff? Yes. Compound. So my compound would go under the yes box. The example is going to be pure water. And then my picture is going to be those little Mickey Mouse molecules. So back up to matter. Is it made of different stuff? Yes. Mixture. So with my mixture, is it uniformed throughout? So where it means uniform throughout, meaning are the molecules all the same all the way through it? If I took a sample of it, no matter where I was at, are they going to be the same? So are they the same all the way through? No, then that's heterogeneous. I mean, it looks the same on the surface, but if I took a sample, it might be different at each space. So my example is wet sand. And then you're going to sketch a picture of that wet sand. Is it uniformed throughout? Yes. Then that means it's homogeneous or homogeneous. And so that's going to be if I look at that cup of tea, the tea looks the same through the whole thing. It doesn't look less dark or more dark. It's going to be all the same all the way through. So my example is tea with sugar. So tea with sugar, and then I'm going to sketch a picture. And we get into these guys here with this heterogeneous mixture and homogeneous mixture. And I realized that the picture is flipped from what your notes are, so I apologize. So I'm going to look at the bottom to help you fill in your notes first. Heterogeneous says a mixture made of different stuff. Heterogeneous. Mixture made of different type of molecules. And then in the parentheses, I'm going to put mixed, because it's going to look like it's mixed all the way through. If you go down to the homogeneous mixture is made of lots of same stuff. Mixture made of lots of same molecules. So in the parentheses, I'm going to put same, because it's going to look the same the whole way through. My examples of the heterogeneous mixture. So if I look at the pictures, I have ice water, because if I take a sample, I might have a big chunk of ice, I might have a little chunk of ice. Soupy noodles. If you take a sample of your ramen, you may have one where it's all noodles, you may have one where it's the little peas in it, or the corn, or the pepper flakes. Assorted candies, M&Ms, you never know what you're going to get. You might get a handful of purples, those are Skittles. You might get a whole bunch of green, and maybe some browns. Assorted dried fruits, soil, oil, and water. You're going to pick two, and write it in that line where it says examples of a heterogeneous mixture. Ice water, ramen, assorted candies, fruits, soil, oil, and water. Homogeneous or homogeneous mixtures. I'm going to pick two. Remember, these are the ones that they're going to look the same the whole way through. So tea, fruit juice, medicine, honey, milk, and blood. So the way we were thinking about this with my 6th grade class, right? A homogeneous mixture. If I get a vanilla milkshake and I put a straw all the way through it and I pull the straw up and it's clear, I can see all the way through, and it's going to look like vanilla milkshake the whole way through. That would be an example of my homogeneous mixture. If I get a cookies and cream milkshake, take that same clear straw and stick it into the milkshake and pull it up. When I look inside of the straw, the different layers, there might be a section where it's a big chunk of cookies and then no cookies at all. So that would be my heterogeneous mixture. Pizza would be a heterogeneous mixture. Sandwich, heterogeneous mixture. Yogurt, homogeneous mixture or homogeneous mixture. So, hope that helps. And then there will be another video that will be uploaded separately that will be walking you through the worksheets to do with this compounds and mixtures stuff.